So today we're going to teach you guys about Cramer's rule. Cramer's rule is a shortcut formula to find a single variable in a system of linear equations with two or more variables. Cramer's rule uses all rational numbers. This is much easier than having to mess with fractions while solving. Not only do you not have to mess with fractions, but also you can find one variable at a time instead of all variables. So right now what she's going over is called the coefficient matrix. And we have our two linear equations. And she's going to make it into a matrix. And that's how you make a coefficient matrix. So now we are trying to find the determinant. So we're going to multiply 1 times 7 and then subtract it from 5 times negative 3, which equals 22. So the determinant of a 2 by 2 matrix is the difference of the products of the entries on the diagonals. So the diagonals there, you're going to go from top left to bottom right to top right to bottom left. Or actually, no, it's from bottom left to top right. So you're going to do 1 times 7 minus 5 times negative 3, which equals 22. Okay, so now we are at the determinant equals 22. So we're going to call the 1 and the 5 the first column. We're going to call that dx, and we're going to delete that for now and sub in 4 and 8. So here's how it goes. You're going to do the exact same thing to find the determinant. You're going to multiply 4 times 7, you're going to multiply those entries, and then you're going to multiply 8 times negative 3 in those entries, and you're going to subtract the 2. And the 4 times 7 minus the 8 times the negative 3 would equal 52. So to find x, you put your dx over your d, which would end up being 52 over 22. Alright, so now we are going to leave our x coefficients, our entries, and sub in and delete our y entries. And we're going to sub in the 4 and the 8, and we're going to do the same thing. We're going to go multiplication, so 1 times 8 minus 5 times 4, which would equal negative 12. And that will make that negative 12 over 22, and that will be our final answer. Yay! Jesse! So right now what we have done is under the linear equations, we have put the coefficient matrix. So we're going to multiply the coefficients now together in the same way that we did the last, the 2 by 2 matrix. And keep in mind that while doing the Cramer's rule, it must be a square matrix. So we're just going to multiply these together real quick. Alright, so we've done the math, and it would be 72 is that first diagonal, plus 40, the second diagonal, plus 126, the third diagonal, and that comes to a grand total of 238. Okay, so now we are multiplying the red diagonals, just like the other problem. We're going to go 8 times 4 times 6, which is 192, and then plus negative 7. So we took the liberty of doing all the math for you guys. You're welcome. And so our determinant is equal to 141. Let's go math. So we're going to call the first column dx, and we're going to delete those real quick, or erase. And we are going to plug in 10, 11, and 12. And we're going to do the same thing that we did for the first step. And we're going to multiply that. Alright, so now that we've done the math, we're going to subtract the 2, and that equals negative 1,499. Alright, so now we're going to come back and we have the coefficient matrix, and we are going to delete or erase our dy's and sub that in with the 10, 11, and 12 and work from there. Alright, so we did the math, and that all equals negative 1,492. So at the bottom, we have our 2 answers so far, and we're going to work on our z, our dz right now. Okay, so that would be our dz right there. It equals 16. So at the bottom, our final answer is 1,499 over 141. 1,492 over 141, and negative 16 over 141. Because the determinant was negative 41, all of the negatives canceled out. And that is how you find, or that's how you use Cramer's rule for a 3x3 matrix. Bye guys. Bye.